I want to give you a quick introduction to graphs. So in college algebra, when we're talking about graphs, we're thinking of equations like y equals mx plus b for a straight line that you're graphing on an xy axis. You're pretty used to, I think, seeing equations in algebra, and that's what we typically think about when we talk about algebra, and that is a huge part of algebra, is equations and solving equations. But if you know how to graph equations, then you can get a very quick, intuitive understanding of what's going on with whatever type of quantity you're studying, just by knowing what the graph looks like. So I want to give you a quick example of this. Let's say we're going to invest some money. So let's say we're going to invest $1,000 for 40 years, and there are two different ways that we could do this. One way to do this is with simple interest. So let's say we invest $1,000 at 10% simple interest. Simple interest means every year we're going to earn the same amount of money on that initial investment. So we invest $1,000. The first year we'll earn 10% of that 1,000. So 10% of 1,000 is 100. That means during the first year we'll earn $100. Since it's simple interest, the second year we'll earn another $100. The third year we'll earn another $100. Every year for 40 years we'll earn $100. So we can say exactly how much this will be. Each year we're earning 100 times 40 years, we'll earn $4,000 in interest. So after 5 years we'll have 1,000 plus 4,000 is $5,000. That's simple interest. Compound interest is a little bit different. And I'm going to give you a choice between whether you would like to have your money invested under simple interest at a 10% return or compound interest at a 7% return. Here's what compound interest is. For the first year, you earn whatever the percentage is, so 7% of your investment. So for the first year, I would earn 7% of $1,000. That's $70 I would earn during the first year. But the second year, not only would I earn 7% of my initial 1,000 that I put down, but I would also get 7% of the interest that I've already earned. So in the first year, I earned $70 interest, and then I'm going to earn 7% of that on top of the extra $70 for the second year. So for my second year, I'm going to have my $70 plus 7% of 70. That's about $4.90. So the first year I earned $70. The second year I earned $74.90. Still not quite 100, but each year you earn money on what you've already earned. So the question is, which one would you rather have over a 40-year period? And you could go through some calculations to try to figure it out. I think it would take you a while to try to figure this out by hand. But there are nice simple formulas for these, so I'm going to write down the formulas for you. For this first one, it comes out to your amount after 40 years as your initial investment, let's say $1,000, times 1 plus, and then you have your rate, which is 10%. I'll put that down as 0.10, times the amount of time. I'm going to put amount of time as t. So however many years we do this, we can calculate it by 1,000 times this. For compound interest, the equation looks similar, but it's a little different. Your amount after t years is your initial investment times 1 plus, and then you have your rate, which here we're going to have 7%. But then instead of times t on the inside, this parentheses is raised to the tth power. Now, these words may not mean anything to you yet, but I recognize this as a linear equation, and I recognize this as an exponential equation. that immediately tells me I want number 2 if we're going out to 40 years. And let me show you what happens. If you take simple interest, we already said we know what's going to happen. You're going to earn $4,000 extra on top of your 1,000. So when time is 0, you're at 1,000. And then when time is 40 years, you're going to be at 5,000. So you can graph this as a straight line like this. I tried to make a straight line here that goes through those 2 points. The way it works for compound interest, though, is instead of having this shape, it has a shape that blows up as you go out to the right. So it still starts at 1,000 because that's how much we're investing at the beginning. And it grows a little slower than the 10% because it's only 7% interest. So it looks maybe something like this. But it starts to bend upward. And what happens is that after 40 years, if you do 7%, but you take the compound interest, you get up to around $15,000. So this is just a nice, simple example to try to give you an understanding of how, if you already know the way that graphs behave based on the equations that you see, that gives you an immediate understanding of how things are behaving in the model that you care about.